RCH Solutions. RCH and 2015 Visioneers are partners. Actually, we're partners with everyone. The world is so full of opportunity. We just want to work. We work with everyone, and RCH is one of those focus partners of ours. Phil Eschallier is their CPO. He's got 25 years of experience as a managerial and technical computing professional. He sought after leadership and his insights with RCH customers. He oversees delivery of RCH's managed services capability, IT, and is responsible for all elements of customer experience. And then Mike Reiner is the president and CEO. Mike and I have known each other for, I don't know, over 15 years. We've worked together in big pharma, in software companies, and Mike's done an incredible job of taking RCH and bringing RCH to where they're at today as a global presence for laboratory and scientific informatics. I'm going to hand it over.
Great. Thank you, John. Thank you for the kind introduction. Hello, everybody. We're getting off to an early start, which I'm sure you're not unhappy about. Today, we're going to talk about the next generation compute environment and what that looks like and how you can build that to the future. So we're going to do an introduction, we'll do a background. We'll talk about certain considerations for driving this whole modernization movement. By modernization, I'm talking about the next generation in the cloud. And then we will speak about real life examples of customers we work with, big and small. So enterprise, large, emerging, and startup as well. And then if we have time, we'll certainly save some time for the end to answer any questions you might have. So as John mentioned, I'm Michael Reiner, I'm the CEO of RCH. Phil is the Chief Technical Officer. We've worked together now since 2016, running the company. And the good news is we're growing rapidly. We're in a really good space, which I'm sure you know, and we're excited the opportunity to work with you guys and talk with you today. So I'll talk a little bit about what we do, where we've come from, and I'll kind of tee this up for Phil because Phil's going to talk a little bit more detail about the cloud and the journeys we've had with customers. So a little background on what we do. We're a full service scientific and technical computing managed service provider. I know that term's been thrown around a lot as a managed service provider, and I can differentiate it with it briefly. We've been in business a long time, 30 years, well established. We've got a lot of customers, you can see, a lot of big customers. But as I mentioned, the bulk of our work now is being done with emerging companies and startups, which is both exciting and interesting because as you can imagine, you can get a lot done, demonstrate a lot of value in a short period of time. We've grown significantly, like I said. We have folks all over the globe, right now physically located in North America and over in Western Europe, but we do support customers all over the globe. So what we do and where do we sit? Well, we sit between IT and the business. And why do we do that? Well, you all know what's happening in the industry. You have IT, which has a service model, which is good for all of the business and may fit most of the business, but not necessarily in the business of science. And the model that they have in place doesn't always accommodate the fast and changing needs of science. So RCH sits in the middle, and we sit in the middle in terms of the science we offer by a complete complement of people, technical people and science people as well. An ideal situation, we help bring them together. We are, what's the term now, bilingual or trilingual. We can talk business, we can talk science, and we can talk executive as well. So we're going to talk about this whole modernization movement and this big idea. We'll talk about the trends and the challenges and the opportunities to push this movement forward. So a lot of this, you're going to see, this is not new to you guys. This is still the same. There's transformative technologies coming all the time, both on the IT side and on the science side. As John likes to say, digital data is a new currency, and it needs to be managed in a much more effective way to improve outcomes and collaborations between groups, and then ultimately get to faster scientific, faster and more accurate scientific results. So what does this do? It's creating pressure for all of us, right? And I also talked about I didn't talk about, but I can't forget about the other things that we necessarily can't change. And these are familiar too as well. I often say there are three things that affect a business. One is the economy, the other is competition, and the third one is people. Two of those you can't change, but one of them you can with your people. Whether they're people that are directly working with your partners, you can empower them by putting the right tools in the right position to make sure they're successful. Now I'm going to jump over what we talked about, which is a cloud. And this is a definition that, Phil, I don't know if you coined it, maybe you can comment on this, but we look at the cloud as the new operating system. And we want to talk about the benefits of the cloud as a new operating system, but this is a chance to hand this off to Phil. And Phil, you can elaborate a little bit more on what is meant by the new operating system.
Yeah, thank you, Michael. I wish I could take credit for the saying. No, we just stole it like most people do. But yeah, we look at the cloud. I mean, it's not only transformative, but some people still look at the cloud as, oh, it's a place to spin up virtual machines or whatnot. If you look at it purely as a virtual hosting environment, you're probably missing the boat. Really, the value here is that it's a whole set of federated platform services. And so, whether you're a Mac user or a Windows user, you wouldn't just use the CD command, but not the dir or ls command. You're going to use every command that's in your laptop or on a workstation to get the most out of it. And the cloud is the same way. So you're not going to simply use it for virtual hosting, but you string together a set of platform services to meet needs. And the multi-governance model we'll probably touch on a little bit later, but the idea here is that it really is a transformative tool that leads to scale and innovation.
Great, thanks, Phil. Okay, so what is this big idea? What is this need to modernize and build a proper next generation compute environment, whether it's the cloud or a hybrid model in the cloud? So we're going to talk about specific areas. We'll talk about real examples of this next generation success. We'll focus on areas, we'll talk about strategies, and we'll talk about some tactics to consider as you evolve and step into this next generation compute environment. So there are specific steps, and we're going to touch on all of these that you need to implement a next generation compute environment. So number one, you need to recognize what the challenges are before you implement and put in place a strategy. It sounds fairly simple, but you'll be surprised how many customers we work with that don't implement the strategy. And the reason they do that is a lot of times the people, especially that have come from large pharma to an emerging or startup, you've left with the scars of what you had before and those behaviors. And what we've seen is this tendency to transfer that to another company, and for good reason. You want what you want. You have things you're comfortable with, and you want to protect that and build that out properly. But it's really important we're finding, and we get in conversations with the customer to understand what the strategy is, or to help them design a strategy, not just from the business side, but from the IT and the corporate side as well. The next one is you put together a foundation in place. And this is really important. It's no different than building a house. You have to have the proper foundation in, the right operational models. Otherwise, it's gonna collapse among itself and fall down. And then second is you need to optimize those investments you've made, whether it's physical hardware with scientific instruments, or whether it's software, so you can optimize the data that you're looking to generate and manage and utilize. And then finally, to put a wrapper around this, because I'm sure you've all seen what can happen with the cloud, especially when they open the barn doors and give people access to all those neat tools. You have to put the proper controls around them, not just cost controls, but the proper guardrails to make sure that you continue down the proper journey. So we're going to give you 3 examples, and I will start with the technology part. I want you to think in terms of a stack, and this goes back to the world we play in the compute stack. The bottom layer being that infrastructure technology layer. The next layer up would be the applications or the workflows. And then finally, it would be the best practices that come as a result of that. And the best practices can include those automation tools or that security. So first example is a specific client we've worked with, an emerging space. So they implemented the public cloud, or they took advantage of the public cloud, and they had a single cloud instance. And what they wanted to do was make sure that in order to build upon that, they had the proper controls in place. So Phil, do you want to talk a little more specifically about not just what the challenge was, but what the solution and the eventual outcome was for this customer?
Yeah, so this like we see a lot of the startups and emerging, they get lured into they find a template on the internet, and they'll create, they'll start up an AWS account, and they'll use this template to get out some basic infrastructure in the bio IT space. And it's attractive, right? I mean, it's low barrier to entry for them, but they quickly find out that it's really going to limit their evolution. And the problem with the single account is that it limits scale, as each account, AWS in this case, will have resource limits. Further, if there's a single account, that means a single governance model. Plus, if anything goes wrong, any of your compute goes wrong, it's likely to impact whatever else is running in there. So AWS promotes this idea of multi-cloud model for public cloud in general, but AWS specifically here, that works to address the limitations of these concerns, as well as lend itself to multiple governance models. And if something goes wrong in a multi-account model, you end up limiting the blast radius. So you want to compartmentalize your compute so things don't go wrong or spill over, yet remain federated. So over the last couple of years, RCH has developed a reference architecture for life sciences compute in the public cloud. And it not only helps with scale, but again, comes back to the opportunity for multi-governance model. And along with this, we've been a long-time advocate for a company and a service offering they have called Turbot, which does automated guardrails in the public cloud. So we've taken this architecture, glued it together with our automated cloud guardrail offering, and we productized it and call it under our Launchpad offering. But for this customer, we don't just go in and say, okay, well, here's what we have to offer. We work through their existing roadmap compute priorities. We implemented this reference architecture, including the automated security guardrails, and then we migrated their legacy processing and data to the new platform. Yeah, I keep telling customers that this type of foundation is imperative for long-term success. But the priority over time comes with what comes next, which is the innovation that we build on top of this foundation.
Great. Thank you, Phil. Okay, so that was the first example. Let's talk about the second one. And this is that next layer up. Once you have the foundation in place, we talked about optimizing the applications and data workflows. So this customer was actually a startup, a biopharma startup, but what they wanted to do was they had started down the path of the cloud, and as they grew exponentially, they wanted to bring harmony and scale, and as Phil alluded to, increase the functionality that they had when they were optimizing the cloud. Phil, can you talk a little bit more about this customer?
Yeah, thank you. So this is a newer customer, and they were a little bit further along than the use case I just was mentioning, but they had put together a number of well-designed compute services for scientific computing. But here, the challenge was that really, quite frankly, some of these services need a little bit of polish. Some of them need some performance tuning, and a couple of them just weren't easy to use. So again, relatively new engagement, but here we have a mix of cloud, HPC, and Linux engineers collaborating with the customer to modify these services as the stakeholders and the scientists prioritize their needs. A couple examples include the need to better share scientific data across AWS regions, or making HPC more accessible to scientists and helping their applications and workflows leverage HPC services. And then data is important. So there's a lot of work facilitating the access to our relational database hosted data, make sure it's available to these workflows. And better leveraging the cloud for high-end graphics workstations. The fact that you can spin up, spin down stuff in the cloud is very important, but graphics is always a challenge when network is a bottleneck. And then as they look to evolve, we've been doing some collaborative consulting around containerizing workflows. Now, you guys may hear this and go, wow, RCH is just doing break fix. But we expect to be involved more in pending evolution of their compute platform. But today, for this customer and this type of work, our measure of success is really simple. We want to make it work better. And when it's working well, we want to make it work faster. And the data needs to be accessible. And in all cases, we want to make it easier to access and integrate.
Bill, before I talk about the last one, I had a thought, and that was building this repeatable service. And you touched on it, or we noted it in the last slide, but we didn't touch on it. That's infrastructure as code. Can you talk about how we've done that and how that can be gratefully beneficial to customers, both large customers and emerging customers?
Yeah, so infrastructure as code, at least to us, is an absolute must as far as a best practice. And that, just like you code software, those not familiar with it, something like Terraform or an AWS cloud formation, you end up writing code when run generates or manages infrastructure. And within that, there's other technologies for automated provisioning. And you end up having everything templated so it's repeatable. If you're in a situation where you have to qualify hardware on your road to validation, then it actually simplifies things a lot because you end up qualifying the workflow being the template in this case, and then the rinse repeat is by definition also qualified. Of course, you got to do some paperwork, but it makes it pretty easy. And if we get on to this last example we're going to talk about, there's another advantage that I'd like to hit on as well, but in that context.
Yeah. So these two, the last two we talked about, emerging and startup, were the exception, but it's kind of the emerging exception. And I mentioned that because before I get to the last one, which was a typical engagement with a large pharma, I mentioned how exciting it is to work with emerging and startup companies for the simple reason is they have the flexibility to do things early on, right? It's a blank palette where they can start from the beginning, create the proper strategy, put the proper foundation in place, and put themselves in a proper position for success. And I'm not just talking about research and early discovery, where we did the bulk of our work. I'm talking about across the enterprise. We've been in engagements where the good news is if it's a smaller company, you get all the people, the proper seats at the table, the business people, the IT people, the submissions folks, the security people, and the attorneys, the legal folks, and they can all share their needs, which is harmonization, collaboration, and sharing data. And you can demonstrate a lot of success by putting that proper foundation in place and build upon it, no matter where you come into the journey with the smaller companies. The larger companies, sometimes that can be a bit of a challenge. Like John mentioned, we've been around for a long time. And for the most part, I was working with large pharma, and it was typically, they would bring us in to fix a specific problem. It wasn't, hey, come on RCH and come on, take over our whole compute infrastructure or append our team. It was fix a specific problem. So this particular customer, we were brought in to help them manage a specific problem around cost and resource management. Phil alluded to the tool in Turbot. So they had embraced the cloud early on. This is 6-7 years ago as a strategic platform, but they were just getting going, and they were utilizing this tool early on to put the proper solutions in place. So I'm skipping over a lot of stuff, but I'll let Phil talk about how we came in, where this evolved to, because even though it was a large pharma, it's something we're very, very proud of, and where we can transfer that knowledge and potentially that recipe for work with customers of all size. So Phil, you want to talk about a little more specifically how we came in, the solution we put in place, and maybe the additional challenges we encountered and where we've got to now.
Yeah, so this is a longer term customer for RCH, and brought in, I think it was 2016. And our initial remit was centered on cloud ops and security, and it was really just keep the wheels on the bus. But I'm always reminding people that a key facet of the RCH value prop is we could take care of the entire solution stack. It's a differentiator for us, and it separates us from other providers, as we can offer IT and bio IT services via small, cohesive, and effective teams, without your traditional IT silos. So as we gained momentum, and we said, they said, oh, can you help with this? Can you help with that? And we kind of grew our footprint there. And it got to the point where, like all customers, they wanted to make sure their cloud spend was effectively used, but also efficiently. So RCH focused on a series of initiatives to monitor and manage cloud spend. And some of the outcomes that we took on and helped them with were right-sizing cloud services. Sometimes in a self-service model, people go, I'll just take the biggest one, or whatever, and it ends up being very expensive. But we used internal and third-party tools to go through and identify and then update cloud services via automation, again, for that right sizing. But we also dug a little bit deeper and looked at the architecture in places and found that if we re-architected certain parts of solution stacks, we could better help get the best out of consumption spends on platform services. And then back to the infrastructure as code mentioned earlier. So we've been using this all along for this customer, but what we had ended up doing was taking this practice and working with other teams, both IT and on the science side, to help them understand the merits of infrastructure as code and start getting them to use this as well. And then, so, as advocates, we step forward and really the repeatability adds efficiencies while also removing the costs associated with human error. Then one of the greatest things about the cloud is elasticity. And so we had introduced, as part of this, some Kubernetes and some HPC models which are elastic, and then as back end to science workflows. And not that HPC wasn't already in use at this place. I mean, all pharmas are using HPC. But here again, the focus was about cost management for certain kinds of applications rather than using HPC simply for scale. And then another thing we did was we developed automations to shut down, not terminate, AWS services that were idle. So if you're not using it, you're not paying for it. And we also provided web-based tools to allow scientists on a self-service model to go in and restart these services as needed. Again, pay-as-you-go elasticity is fantastic, but if your scientists or whoever the users are just leave it on all the time, you're going to drive up costs. And then for the components that need to run long-term or pretty much full-time, worked with the customer to figure out the right mix of savings plans and other discounts offered by the cloud vendor in order to make those long-running tasks more cost-effective. So these guys, I mean, yes, you'd like to think that you're saving money, but these guys actually continue to grow their cloud spend, which is fine. Because it's not necessarily about minimizing costs. It really is just making sure you're getting the best bang for your buck. And this is something that will probably never end because there's always new platform services being introduced. Look, workflows are ever evolving. So the strategy and tact that goes into cost and resource management is always going to have to shift to match what's going on underneath, day to day.
Thanks, Phil. Yeah, I'll leave you with this, that the cloud is the next generation scientific computing tool. And we talked about the need to modernize. And it's not just grab the shiny new objects and try those tools, but we're here for the evolution. We've seen a lot of this before. We've helped guide our customers, whether it's from strategy to execution or actually ongoing support. But we're here for the evolution. Like I said, we have a lot of experience. I know we flew through these examples and touched on them briefly. We'll be happy to talk about this in greater detail. So we've helped customers, as Phil mentioned, complete them faster and scale so it can evolve and grow, recognize the return on investment that you can actually demonstrate for people that are paying for this, and ultimately achieve outcomes. And you'll see some labels here on the right, just a handful of some of the customers we work with, but there are certainly many others. We'd be happy to talk to you about specifics about what we've done if you have any questions. And yeah, right now we can open up for questions. Phil and several members of our team will be available throughout the next couple of days as well. So thank you, everybody. John?
Yeah, great job. Yeah, if you have any questions for Phil and Michael, just put them in the chat while we're waiting for any of those to come through. Something that I get asked a lot, and you guys really are like definitely the broad computing expert It's in your DNA. You've been doing it for a long time. But as you know, sometimes we get different clients that are at different parts of the evolution, right? It was kind of when I was talking about before technology and, well, we just bought all that last year or 2 years ago and we still haven't depreciated. And there's no way we're going to get approved to do this or that. But there's things like edge computing, there's cloud computing, and for some of the larger clients, it might make sense for them to transition, to a much larger cloud deployment or cloud first strategy, etc. Do you guys get involved with that from like an edge computing perspective, where there might be a reason or a need to have some of that computing very close to the automation or the manufacturing or whatever it may be?
Yeah, so good question. We see, and we were really advocates of edge computing from the facet there's parts of the public cloud that won't have certain services, maybe deep into programmable FPGAs, or some people will say there's a problem with AWS, like GPU is expensive, or maybe they're having a hard time resourcing it. So having GPU farms at the edge, topologically close to your data in the cloud, often makes a lot of sense. But what I think is and very valuable, but what I see coming up is really the emergence of cloud labs. And you think about a customer or an organization, life sciences, they go out and they buy a high sequencer that generates a lot of data, or the newer thing now is the cryo-EM. So much data, but they don't have the bandwidth, the network bandwidth, to get it into the cloud in a timely manner, where the cloud labs are well connected. So if an organization is cloud first, at least for their research, and they're using the cloud lab, the ability to transfer data in a timely manner from the source into your analysis pool is so much better. And look, all pharmas seem to have this problem too. It's, hey, I'm going to buy a cryo-EM, but they don't put anything on a purchase order for storage or for supporting network. And I keep saying to the procurement folks there, why don't you not allow an instrument purchase if you don't have the supporting infrastructure as line items? But that doesn't seem to go over well. So cloud labs really seem to answer a lot of what's going on, or the potential concerns, with data generation, data movement, and just can't wait to see where it goes.
John, we had a couple of questions coming on the chat, and one of them I think touches on that. The ask is, what do we think is the next big innovation to hit the compute environment? I think on the science side, like Phil mentioned, cryo-EM seems to be the biggest one, and then it's a proper business practice of how you get that implemented. To your point, you're going to spend all this money. Maybe you should think about how you're going to roll this out and properly support it. The other one I should have mentioned in full disclosure, as far as the next big innovations are, at least on the infrastructure side, we are vendor agnostic, and we choose to be so because, number one, we're primarily a service organization. We can get anything to work within reason, but at the same time, it allows us to be objective in speaking to customers, whether they're purchasing something net new or, like John said, hey, we made this big investment, we've got this stuff already in place. How do we leverage what we have or utilize something like the cloud or an edge computer environment for a specific application?
Yep.
Phil, there's another question that came in.
I think the first one might be for the roundtable, but I think the second one was definitely for you guys. I think.
Okay. So we'll hold the
yeah, we'll save that for the roundtable. We'll get the.
All right. Okay.
Yeah, no, I agree, and I think access, just like fair, findable, accessible, interoperable, reusable, that applies to not just to data, but to processes, to the cloud, to different things. And I think as the technology for internet access improves and increases, it's going to start changing the way certain things are done today, or allow things that we have trouble with today to occur in the future. But there's definitely, it's definitely not 100%. It's very difficult to take a large organization, say, oh, you're going to be cloud first and everything is going to go to the cloud. It's a very multi-year process, and a lot has to happen. But as you guys mentioned too, it's like with the startups and the smaller companies, they have a clean slate. They don't have all the issues that some of the larger organizations have. Not always, but usually. So if you can get in early, you can make a lot of great things happen from a cloud first strategy.
Yep. Yep.
Yeah, very cool. I'm just trying to think. I think what we could do is we're really close to the round table. So why don't we start the round table, and everybody that wants to be involved in the round table, we can all go on camera. And then now the round table is kind of not a total free for all, but everybody's allowed to ask questions and of each other and of the round table. I think it's kind of based on some observations today, between Stratios, OpenEye, Watershed, Arcturus, and RCH. There's some themes that are coming out here, and I think one of the vectors of direction and magnitude is the reproducibility, right, as the big one. And we could. It seems like a lot of companies are happening because of that. And it may be directly or indirectly, but it'd be interesting to hear everyone's thoughts on why do you think we're in this reproducibility problem, right? What's caused it, and why can't we get to the root cause of some of these things and fix them? I personally feel it has a lot to do with the culture of the environment, but it would be interesting to hear why everybody feels that we're still suffering from scientific reproducibility. Just open it up. Whoever wants to go first, just hear your comment.
I think it's standards, right? It's a lack of accepted standards across the entire industry as a whole. If you don't have everybody speaking the same language, then reproducibility becomes an effort, and reproducibility isn't necessarily what makes the most money.
Right. Okay. Anybody else want to comment on that before I say anything?
I mean, one key condition, I think, which goes beyond standards is that at the moment we don't have a very good way of capturing information in the first place, because a protocol, the way it's currently being written, simply is not sufficient to actually understand what has happened. There have been some very good papers on reproducibility, and the examples they show is that two labs had to mix cells, and one of them was very, very gently shaking them in one device. The other one was stirring them quite rigorously, and that changed cell behavior completely. But at the moment, we simply don't have the way to describe that appropriately. So I think that's why the concept of metadata in itself is so very important.
There's a famous quote that says, you can't fix by analysis what you've bungled by design. I think, from Martin's viewpoint is very accurate there. So it's not just, standards, it's also protocol implementation, but, equally important is understanding, variables and understanding, is there lurking variables out there that become confounding, right? And you might not even be aware of that when you're actually doing scientific discovery, and having a system where you can identify those variables, the metadata, the environmental variables as well, is extremely important as we go from, tools that are, really, I think, first generation designed for kind of for analytics tools, going more into design tools, and then laboratory orchestration tools. So I think it's all of those factors that are really important for not only reducing variability, but also increasing accuracy.
Yep.
Yeah, I think that from our perspective, being more of a platform and infrastructure service company than actually doing the science, we try to have engineering rigor in what we're doing, in the reproducibility, the infrastructure as code that I mentioned earlier. But for years, we've watched our customers struggle with reproducibility in that, well, if you generate data, how long do you have to keep it? And a number of our customers just say, well, we need to keep it forever, because they're not confident that they can reproduce it. And that's great if you happen to be a storage vendor, but there's no confidence from the beginning that certain things are readily reproducible. So it seems to be something that it's pervasive.
All right. Well, I look back in my career, and I look back with all the people that I've worked over the years, and all the clients we have, and I see this. There's definitely a lack of the scientific method, the ability to record and stuff. And I wouldn't say, and we have plenty of technology and stuff today, but even with a well templated ELN or a dynamic ELN and drop downs and all this stuff, there still seems to be a lack of ability or capability to, capture properly. And I think it comes down to the fact that is technology going to have to force some of this to drive the reproducibility? Because if we rely on human to capture that data at the time of design and the time of data capture and stuff, I don't think we'll get there. That's what that's after years and years of observing this and seeing how it goes. And then a lot of excuses happen too. Well, this is research. We shouldn't do that, or we shouldn't have to do that. I mean, I hear lots and lots of excuses. But it's industrialized science. It's not like it's industrialized science. So, well, I mean, what do you guys think? I mean,
So-
Mark and Ash, you guys are building platforms that are driving to capture this, the reproducibility, et cetera. So, yeah.
Yeah, from my perspective, it's a two-hit problem that both we don't have automated methods by which R&D teams can capture the requisite data, and B, even if they did happen to capture all the data, there's no way to easily pair that metadata with the underlying analyses on the compute side, right? That it's not easy to ask the question, what does my PCA look like colored by the temperature down to the down to the tenth of a Kelvin on my media, because those two systems are separate. So I think it's going to be crucial to both take humans out of the acquisition process, like you'd said, and then make it seamless to pair it with the analysis, right? We need to be able to have ELNs plug seamlessly into products like Watershed and the other cloud providers.
Okay.
Yeah, I think, the feedback loop is where that becomes especially important because, as someone who works on a computational drug design platform, what happens when the data that predictive models that we build or the data that we generate sort of gets thrown over the fence on the experimental side, right? Now it goes into synthesis, it goes into assays. And in many ways, what's been missing from the process is tying all that data back from the assays and synthesis, back into the computational drug design process, right? Setting up that loop. And that's one reason, I always love the work that Stratios is doing, right? Because it gives us a chance to really make both experimentation and computation part of the same platform, but then tie back all the metadata that you just don't have at the beginning. You bring it all back and then see how it compares to your initial hypothesis and models.
At the end of the day, though, it's going to take us all just getting out of our own way, right? So Arcturus has their structure where he's just talking about where they sort of streamlined out the process for setting that protocol. There's auto protocol that's out there, right? That's what we use. We use that same thing.
Yeah.
And then on the other side of that, like Pistoia Alliance has the Data Fairy bioassay annotation, and that's who is that? I actually have it up because of that question. AbbVie, BMS, Novartis, Roche, GSK, AstraZeneca. That's the steering committee around it. So it's on both sides, right? And if the standards become set, and then we can all just hook into those standards, everything becomes much more interoperable with that. And then reproducibility becomes just another part of your standard process.
Yeah.
Also, what's really important is how we publish results. A few years ago, maybe about 10 years ago, there was a tool that, on NCBI, where if you were a published author, there was a feature set called, I believe it was Pub Commons, where you could actually go in there and debate people about a certain result in the paper. And I think the most ultimate kind of form of reproducibility is a future where we go to a paper and we click on a protocol and there's a cloud lab somewhere that initializes that protocol, then generates a result. And that form of that form of protocol implementation, right, is then creates a situation where you have the kind of most extreme form of reproducibility you can track across different platforms, and you know exactly what an overnight incubation is. It's 12.2 hours, right? So I think until we get to a world like that, where we start incorporating these tools and then they're deployed across, you know, multiple companies, right, we're going to still have these significant challenges that we face.
Yeah. Agreed. Okay. There's a question in the chat. Do you think we're at a tipping point in terms of modernization in R&D IT? So I'll throw that out there. And I guess that's the question. So is R&D IT significantly changing?
I think it better right now, right? The current setup is bursting at the seams, right? We have petabytes of data lying around and no way to efficiently, performantly crunch through them in a fair manner for deriving insights. So I think we don't have a choice. I think the infrastructure has to evolve and to meet the needs of to meet the needs of these high throughput versus low latency compute needs, right? That fundamentally a lot of the computing and subsequent infrastructure required for the kinds of tasks that we're doing in bio IT are different than what AWS or GCP is set up for, right? It's not Netflix streaming a million movies. It's efficiently and performantly crunching through 50 terabytes of whole genome sequencing data in a way that automatically keeps track of your data provenance. So the short answer is I think it must, and we're in the process of doing that. There's a few players helping.
Yep. Anybody else want to comment on that?
I think one of the steps in modernization around R&D has a lot less to do with the actual science itself, but more on the accessibility, right? So we talked a lot about the cloud labs and all of that type of stuff, but how do you get to the cloud lab, right? So if you're coming to Stratios, then you use Lodestar, right? Or another company uses this or that, and there's not really a prevalence of market makers out there for this type of technology that really enable it. But there are things that have started to develop and started to catch on, like cluster market and organizations like that. I think development of market makers for really these industries as a whole would be a huge way to launch it into that modernization area.
Yeah, I think there's technologies moving quickly. Science is certainly always a factor, but I still come back. It comes to me, it's governance. And, especially the bigger organizations seem to want to take R&D IT and make an extension of the enterprise IT, which succeeds on the one-size-fits-all model. And as long as R&D IT can be nimble enough to adjust, pivot, and address the discovery needs, in earnest, I think it can keep pace. I think if you get stuck in the old days or you try to manage it like the enterprise, you're going to stall.
Yeah. Okay. That's good feedback. Let's go to this one. How can we better drive adoption of all these great tools? We know scientists are skeptics and aren't often resourced to use, adopt, build new tools together. How do we solve that?
Wow. So I have the exact opposite perspective because I read about it Friday. How come it's not in production Monday? So I feel like adoption, I don't know, that might be like someone within a certain segment having trouble might have to dive more into that than I could.
So my own experience is that it oftentimes helps to do this the way that many other technologies have been adopted, which is you start with someone who's really enthusiastic, who's really open to try something new, really open to change the way things are being done. And from there, it starts disseminating across the field, across the space. More and more people use it. Some thought leaders start using it, and that's the way when things get adopted. I think there are very few cases when everyone immediately jumped on everything. And let's be quite honest, scientists are reasonably conservative people. They're curious about what they're studying, but the tools are oftentimes tried, tested, have been around for a very long time. That's at least kind of the way that I've And we've kind of experienced it oftentimes that you work your way from early adopters to then having more and more people seeing the value and changing then the way they do things.
I think at this point, Martin, is fine, especially when you are talking about the small organizations. So a scientist can try new things, and then, as you said, some others look at it and say, "Oh, it looks to work fine," and then they try it. The problem is when you are dealing with big pharma companies or with big enterprises where there is a culture already established, and changing things and changing the way things are being done is harder. So for these organizations, there is a need for a culture change, and the management change, change management, sorry, it's a very difficult task. And it's something that really takes time. But as you said, having good data and good outcome from the new approaches is the best way to spread the gospel, if you want.
Yes, but you will always need a champion. You will always need early adopters, and whether they are individual scientists or VP level or C level doesn't matter, but you need a few people who start the journey for the organizations. And we work with top 10 pharma, we work with small companies. It's always the same thing. You need a handful of champions who lead the way.
Yeah. In your experience,
Sorry. No, go ahead.
No, yeah, I was just going to ask, following on this same line, Martin, in your experience, I mean, the experience of all the others, your senior people with a lot of years working in many companies, what is better? I mean, a change that comes from the top to the bottom, or from the bottom to the top? I mean, C-level imposing or suggesting those changes, or those changes that start from the very bottom, from bench scientists and engineers. What is your experience?
I was just going to say there's a sandwich effect. If you want to get the optimal, you get the top down and the bottom up at the same time, and then the magic happens in the middle. But go ahead, Mark.
Yeah, I was about to say the same thing. At some point, everyone has to be happy with what they're doing. And of course, the reasons why some people would want to try a new solution will be very different. A chief financial officer will have a very different incentives to trying something new compared to a bench scientist, compared to the chief scientific officer. All of them have very different reasons why they might be inclined or less inclined to try something new. And I think I've rarely seen a pure bottom-up or a pure top-down approach. It often takes a few touch points at various levels, which then make things happen.
I just wanted to say something about, getting scientists to accept results. I mean, ultimately, coming from a very science-driven company, one thing that we have found out, certainly in the field of computational drug design, is that the data really speaks for itself. The proof is in the pudding. Scientists, they are very data-driven. Ultimately, you show them something works, and then they're much more likely to accept it. And one reason why I say that is because at OpenEye in particular, we have placed a lot of emphasis on validating our tools, and we are always very reluctant to try to pitch a tool that's not very validated. And that generally has worked to our favor. So, run sort of the kind of virtual double-blinded trials of the kind that they run in clinical studies, and really sort of demonstrate from a rigorous standpoint that your tool is comparable or better. And that certainly goes a long way. So.
Yeah, this is the classic innovator's dilemma, right? I mean, you have multiple examples of this, obviously even outside of science, or examples of that, with insulin, right? I mean, porcine insulin took, was displaced after, 20 years of recombinant insulin as, the most frequently used, treatment, right? So it's challenging because there has to be incentive for people to want to change. And I think that's the key component here, is to understand the current pain points, and then set up a process. Part of that is change agents, it's data governance, it's all these things that we're talking about. And it's also, providing kind of handholding throughout the process to show that there is a return on the investment. There is, the juice is worth the squeeze, but that's hard when people are trying to balance the operations of their daily job, and then balancing that with maybe even shifting how they're doing things as they're going through this digital transformation initiative.
Yeah. So what we're hearing is that there are multiple variables in this equation, right? And there is no one answer. And I think another problem is we're not dealing with absolutes many times in this science, right? We can't definitively put a finger on it and say that's 100% it. Where we might be halfway there, we might be 25% of the way there. And what seeps in are opinions then. right? I don't believe, I don't think, I don't feel, and that just becomes part of the environment. Then that allows people to stray from adoption of standards, or I'm going to create my own standard, right? So this is what happens in the space, and I think we've been able to learn from like the semiconductor industry, where there are more absolutes, right? Where they were able to nail down standards and adoptions. And I think this is part of the education that I think is missing in the earlier years for a lot of people, is if this could be taught better and brought out better, we might get to a point where people are willing to put some of these things aside and do more adoption than trying to recreate the wheel many times.
We also need to keep in mind that as innovators, we're the only ones that actually want to take the time to do it. The people that are out there doing the work, and day to day, they're trying to create a product, they're trying to get something off the shelf, they're trying to get the science done. They don't have the time, that luxury that we do to do this development. So when we do have that proof, and we are ready to communicate that out and get those adopters of technology, we got to be able to prove it, and we got to be able to do it easy. We have to make it easy for them to accept it and adopt it.
Right. So we need better data cultures, better process cultures, and the ability to drive those strategies with everybody on board and incentivize good behavior, right? And I know it sounds a little silly, but from everything that I've seen, it's a big part of the problem, right? And if we can do a better job at that, a lot of, for instance, COVID, I wondered, is COVID was it going to take 4 years to kind of fade away a little bit, or no matter, what we threw at it, what we weren't going to lessen those 4 years, or could we have gotten through COVID, not necessarily it disappeared, but could we have gotten through a lot of it 50% of the time if our world's scientific data environment, misinformation, you just go down the line, was in much better shape, right? I kind of think if we were a lot more mature, we probably would have. Okay. Anybody want to ask any questions inside the group here? Because you've all been here all day, so it'd be great to see if you learned anything or saw anything that was something that you wanted to ask. Okay, I'm gonna say.
I was curious, especially for bigger companies like Martin's company or Mark's company or Phil's as well. As well, all of you are big companies, but Strateos and RCH and Artoris seems to be a little bit well established already, and you are playing with the big ones. What's your view? I mean, in terms of the big pharmas, the big ones, are they willing to start changing their model? They do things and they do experiments, and they are willing to collaborate and work in cloud labs and use AI tools from outside. I mean, are they willing to do so, or they are still hard to take all these changes on board?
My experience so far has been that they are not just willing, they're running towards it. Right? Look what Lilly has done with the cloud labs that we've built for them, and we've got essentially just every time we do one of these conferences or one of these webinars, we're just at this endless line of how do we start, what do we do next, where are we going, how do we get there, how does it improve? Like it is, it's hard to keep up with, to be honest.
Yeah, that's good.
Yeah, I think it's a heterogeneous group. That being said, I think we've started to see a shift towards kind of a digital first strategy, right? You see, chief innovation officers, chief digital officers, right? These are all new constructs for helping solve some of these problems. And you see large kind of mass initiation of groups throughout the industry supporting this digital transformation efforts, much of the time internally at these large companies that we're working with, and they're providing the tools and some of the expertise internally in acquiring kind of staff that are experts in a digital first strategy. So compare and contrast that versus 5 years ago, even a few years ago, we're starting to really see a shift in the paradigm.
That's very good to hear.
Yeah, I think there's a mix, just like everyone here on this panel has a different personality. The different pharmas have each had a different propensity for embracing new technologies. And we see a couple pharmas that are embracing the cloud labs, not quite what the earlier example was, but that's not one that we're actively involved in. But the race to AI is out everywhere, and for good reason. So it really, I think a lot, and some are further along than others. Some have said, well, we're not going to do this, and all of a sudden decided they had to. So now they're 2.5 years behind their neighbors. So I think we're all going to get in that direction, just at a different pace.
Mm-hmm.
Okay. Yeah, I know everybody on this call's very busy. So, and my predictions normally come true. So you're going to get even busier. There's a question here. As you look across your clients and engagements with large pharma, what are some low-hanging fruits that you wish they would do? Or are they too far gone and they need to rethink their infrastructure foundationally? So that's the first part of the question. So low-hanging fruit from larger pharma.
I think the low-hanging
go ahead.
fruit, honestly, just to start, right? So there's various cloud labs out there now. Grab something that you know well, give it a shot, right? And go out and interview with these companies. It's not about starting transformed, right? You don't start as you've done all this transformation. You have to know where you are, right? Evaluate what you've done, what you have, look at the value that it's bringing, the impact that it has at the end of the day, and take it from that perspective of this. Say it's a method, say it's something that you run over and over again as a pharmaceutical company or a CRO, and bring it to these organizations like what we do, and have them evaluate it and figure out what type of impact doing that transformation would bring. And the better these large organizations know those systems that they're working with and can convey that in some sort of regularized format, the better we're going to be able to take it and turn it into something much bigger for them.
Yeah, well,
go ahead. Oh, sorry.
Go.
Oh, yeah, and what I think would be extremely useful is if a lot of these organizations would help reduce the friction to experimentation on tooling, right? That right now it's extremely challenging if you're not the VP of pick your favorite therapeutic area to bring in a tool to test out on your team, especially if you're going to touch any data that's proprietary. So I think figuring out lower friction ways to let mid and low level scientists actually be able to test out these tools be incredibly useful for them to be able to de-risk it from the perspective of, is this worth shoving through procurement for the next 3 months?
Yeah, Mark, what you're describing or maybe experiencing is common, right? And it hurts small companies too, because you're wearing multiple hats, you're trying to do everything you can, and a lot of sometimes it doesn't pan out. Sometimes you never even make it happen, and it's a lot of effort spent, right? And it is extremely hard, there's no question. And the parts of the reason is, believe it or not, a lot of these companies are extremely disorganized, right? You would be shocked to see what some of their tool sets are today. So and then to get out of their own way, or to convince a VP or a senior person in management there, it's just really challenging. And it goes back to the top down, bottom up thing. You almost have to find who is somebody that can, basically slip through the pocket with the football and score, right? And it's just difficult. I don't even know how else to describe it.
I'm totally on board with that, John. I mean, I think in large companies, there's always a reluctance to sort of do proof of concept thinking, right? Like, just create a small, I mean, borrowing terminology from product management. I mean, they never really think in terms of MVPs, right? They always have these big projects. And one of the big advantages of MVPs is that you can quickly test something and then see if it works as a proof of concept. And I do think that that's a relatively low-hanging fruit, because it usually also turns out to be pretty cheap to just set up a small set of experiments. And I think that I personally wish there was more thinking of that kind in big pharma or big companies.
But a lot of it, I mean, isn't a lot of it budget? I mean, budget and resources. It's easy to, what's the low-hanging fruit, but they have to prioritize, and budgets continue to shrink. And, my perspective is, even some big pharma, I don't want to say that they deprecate research, but they're definitely not putting the same effort into it as 15, 20 years ago. And they're sitting there watching these emerging companies. If anything interesting happens, they just buy that company. So it's really hard. It's hard to get, it's a big ship. It's hard to get it to turn.
What it is. It's very, if anyone, the folks in this call and out in the audience that have worked in those roles in these companies, I can tell you, it is hard. And a lot of times, I hate to say it, but some people they don't have a sense of urgency, and they don't want to stick their necks out. And it's so frustrating when you're in those roles and you're trying to rally people to do something really good or different or game changing, and you have to deal with that. So, the only thing I can say is just hang in there. Don't lose sight. It's hard, but once it's the tipping point. Once the momentum starts to go, I call it follow the laggard. And I hate to say it in this industry, but as soon as somebody big buys your software, all of a sudden, all the others start to say, "Oh, did you hear so and so? Just went with them," and then it just starts to really grow from there. So
that's why we put logos on slides, right, John?
Yeah. So, but okay, we're getting to the end here, I think, right? We had a half an hour.
Yeah.
Yeah. No, this has been great. Look, we could talk about these things for hours. I think a root cause that I've learned, and what we do with a lot of our clients, is culture. Like, you've got to fix some of this broken culture. Once that's fixed, the strategies become seamless, and people follow them. But when you have a culture of everyone isn't on board, or all the stuff you guys are all dealing with it, you're kind of just like in limbo with a lot of these folks. Sometimes they don't even call you back. You're like, oh, are they super busy? Are they blowing me off? Or what is it, right? And you realize after time, sometimes they're busy. Sometimes people are just kind of unprofessional and don't get back to you. And you're like, I don't want to bug them. But in the same sense, I really want to know, should I move on? Should I do this or whatever? So there's all types of issues, but culture fixes a lot of these things. I know it sounds silly, but it really, when you're in a culture first organization and you see how things really start to take off, you'll become almost a believer, like, hey, we need to do things here a little differently. Scientific data strategies, another example. It's a rudderless ship without some sort of scientific data strategy, and that leads into selecting automation, instrumentation, governance, stewardship. That whole thing is so critical. Like saying, I'm going to run a marathon, but I'm not going to write down my goals, and probably not going to commit to it. I'm not going to sacrifice. I'm not going to, dedicate. Well, guess what? You're not going to, you might run the marathon, but you're not going to do well. Right. And if you don't do these things in life, you're going to suffer. You're going to struggle. And then sometimes we're on the receiving end of it. So, all right. I guess we're at the end here. Great job. Great first day. Look, full transparency. The virtual vendors showcase is something new. I'm trying to champion this. People have a hard time leaving the conference and going in there. So hopefully over the next couple days, it'll get better for everyone. But just remember, I know this sounds horrible, but one client could make all the difference, right? And that's, I hope it's 100 clients, but 1 or 2 clients could make a big difference for all of you. So that's what we're hoping.
Excellent.
All right. Thanks, everybody.
Okay, thank you very much.
See you tomorrow.
Bye, everyone.
Thanks, everyone.
Bye.